Yep, this is today's problem. Have a special
Mhm.
guest here who's gonna be solving it for me. I'll be the interviewer this time.
Oh my God. I'm interviewed by Daryl.
Okay. Um, all right. Yeah, here's the problem. Given n non-negative integers representing an elevation map where the width of each
Mhm.
bar is one, figure out how much water it can trap after raining.
Right. Okay. Um, mm, so I think some random thoughts that are going across my head right now is I think this problem generally revolves around identifying containers of water. So within an elevation map, there are going to be crevices that can contain water,
Mm,
and I want to go through I want to go through and identify those crevices. Now, the reason why I want to do it this way is because I want to kind of do one pass through the array, or rather, make an OVAN solution. So while doing one or a few passes through the array, I want to make note of the crevices. So for me to do that, I think, mm, uh, let's see. So how about I go through an example really quickly?
okay.
Um, so this is kind of so normally what I would do is I would write out test cases.
Mm,
So I can go ahead and do that. So assert that my solution, when run with this array over here, is going to be the same as 6.
mm,
I also want to assert that the solution, when run with this array over here, is going to return 9. So, but generally the purpose of writing out test cases is so that you can visualize the problem or kind of get a better idea of it. But just looking at these array numbers doesn't help very much. So let's go ahead and construct this second example like visually. So we
mm,
have a area that is four high, and then we have two, uh, nothing, three, um, two, and then 5.
mm.
Okay. And then, so to mark down the places where water could go, well, of course, uh, what should I mark it with? With the next. So this place could contain water. This place could. That place could.
Mm.
And that place could. Oh, except for this one. This one can't contain water. Actually, it can, like that.
Yeah.
So count that up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay.
Mm,
So going through this problem, I think what I want to do is um, I can identify what a container is to kind of get at the core of the problem. So I said we need to identify containers. So what is a container? A container is an area that is blocked off by a left and right tall area.
mm,
And so I want to start, maybe I want to go from left to right through the array, and I want to keep track of the, I want to keep track of the tallest wall on the left side.
mm.
Um, uh, Hmm.
Hmm.
Okay, so when I'm when I'm going through the array one by one, I'm going to like I'll find myself in a situation where the container I'm looking at hasn't completed. Like, or in a sense, I've read the left wall of the container, but I haven't read the right wall of the container.
Yeah.
So I want to I want to continually update the water value. And I think the way I can do that is I can start by, so once I found a left wall, I start by assuming the best case scenario where the right wall is at least as tall as the left wall. And then I, every time I find a bar to the right of the left wall, I would uh, subtract that bar's size from kind of the ideal container water. No. So let's say I have this four over here. So like the four in the beginning.
Okay.
In the beginning, I optimistically assume that there is some wall on the right side that is at least as high as that as that four high wall,
Hmm.
and um, and I also optimistically assume that there is actually like all the heights between those two walls are zero. Or in other words, I assume that there are 16 perfectly sized, like 16 like water areas between the two walls,
Hmm.
just as like a blind estimate. And then I go through the next iteration of the for loop. I discover that wall that is size two. I find out that it's not tall enough to form a crevice. So all I do is uh, I say that. Oh no, sorry. So I start with a wall. I don't optimistically assume 16 areas.
Hmm.
I start by finding the left. I start by finding the wall that's four tall, and then when I find the wall that's too tall, I see that it can't form the right side.
Hmm.
So all I say is there's got to be some container like later on. So this is probably going to be um, like part of like inside of the water area.
Uh-huh.
So I subtract two from four to get the number of water elements that are above the two wall, and then I add that to a current water count,
Mm.
and then afterwards I find zero. I see that it can't be the right wall because it's not as tall as um, the fourth wall. Sorry, it's not as tall as the four wall. So I do four minus zero, which is four, and assume that I can store 4 units of water above this array location.
Uh-huh.
Um, and then once I find a wall that is, uh, man, that's tough. Like I think I'm completely lost actually. I
Okay.
completely forgot what my solution
You-
was.
You're you're on the right track. So your current solution right now is basically just like keeping track of like what the value, like the wall on the left, and comparing it with the currents, like how tall the currents one is at, and then like
Hmm.
kind of like accumulating the water as you go along, right?
Yeah.
Another thing you can kind of look into is maybe somehow getting the like the rightmost wall instead. So,
Huh.
but because okay, let's say you have knowledge of both what the elements on the very like okay, let's say like you're here, right? Like you're at
Hmm.
like index number one.
Hmm.
You know what the left is because you've already like gone through it, right? If you could
Uh-huh.
somehow figure out what the maximum value like at the very right is, in this case it's this amount, you
Hmm.
know that the um I guess like the blocker in this case is the height of the left wall.
Hmm.
So then at that point, like like you kind of like are able to figure out like for every single like place like how many like how much it can go. Like for example, let's say like a word one, we know the rightmost is five, and we know the leftmost is like four here, right? We can
Hmm.
figure out how much we need to add at this specific like index by figuring out the minimum of the leftmost wall and the rightmost wall, and then subtracting that from the current. So let's say like it's 4, and then we have 5 over here. The minimum is 4. We subtract that with the amount of the current one, and then we get 2 over here, right? The tricky part is figuring out what the one at the rightmost is. So can you think of
Mm,
a way to figure that out?
right. I'm thinking 2 pointers from the left and the right.
Mm-hmm.
Uh, and maybe I progressively build into the middle of the container.
Mm.
Um, so mm,
Like
yeah.
like you would also want to like so, so there's like multiple different ways of being able to do this.
Mhm.
You can like one potential way would be to somehow like store all like I guess like you said, like you have 2 pointers, and then you have to store like what like the current greatest is from the left and what the current greatest is from the right, because like that's kind of the information you need, right? So
Right.
maybe like you have like a max left here, and you
Mhm.
like you see like what the maximum is, like like this index, like the maximum is like 4, or I guess like the left is 0, like at index 0, like the greatest is 0 because like there's nothing else before that, and then like the next max greatest is 4 because now that you're at index 1, that this one is the greatest, and like so on and so forth. um
Mhm.
Maybe then you could have one for max right, where
Mhm.
it's also the same thing. Like you start off with a pointer at the very end, like the
Right.
maximum there is there, and like basically go on so forth. Like with these two arrays, you could like you could figure out like how much to like determine like how much like water to add at each column, right?
Right.
Does that sort of make
Uh,
sense? Or?
yeah. So first go through and do some pre-processing to make an array from the left side and then on the right side,
Mhm.
where max left represents for each index position, what's the biggest wall that's been seen so far when going from left to right,
Mhm.
and max right represents what's the biggest wall seen so far from going
Mhm.
right to left,
Mhm.
not left to right.
Yeah. And then from there, how can you use like the information of like the current max left and the current max right to figure out how much water to give at the column?
Mm, let me go ahead and draw out this other example because I realize that the thing that I'm thinking about is uh, like in an actual test case, there's not necessarily going to be one nice container like there is depicted on this test case.
Hmm.
So I want to go ahead and kind of write out what it would look like if that wasn't the case.
Okay, okay.
So we would have um, so let's say we have 0, and then we have 1,
Mm,
um, 0, 2, um, and then 1. 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, and then 1.
mm,
Okay. And then the water can be stored uh, here, 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 and here. So I
mm,
end up with 6.
mm.
Okay. Um, uh, so over here, for this small kind of piece of water on the very left,
Mm.
um, max max left would be 1, and then max right would be 3.
Yeah,
Is that right?
yeah.
Okay. So Okay, so with the values 1 and 3, um, I know that it's bottlenecked by the left side, which means that the highest the water could go is 1.
Mm-hmm.
And if so, the highest the water can go is 1 at this position. And
Mm-hmm.
if there is no wall that is at least 1 tall in this area, that means that there is space for water.
Mm-hmm.
So I add to the current water uh, 1, which is the highest the water could go.
Yeah.
And then let's say I go over here, and then I have so here the highest left is also 1 because I
Mm-hmm.
exclude the current position, right? And
Mm-hmm.
then the highest right is 3 as well. But the
Mm-hmm.
wall, so the highest the water could go is 1, but there's a wall that's too high, so it's like I couldn't get any water over here.
Mm-hmm.
Uh, Over here, the highest left is 2, whereas here the highest right is 3.
Mm-hmm.
I see that there's a wall 1 high. The highest the wall could go is 2, so the water could go is 2, but the wall is taking up one of those, which means there is 1 piece of water here.
Mm-hmm.
Is that an accurate
Yep, that's accurate.
solution?
If you had to
Okay,
like kind of reduce it down to a formula, what would it look like? If you're given
right,
like the max left, the maximum right, and like the current value.
right. So I'm thinking that so maybe I would say uh, let me just go ahead and type this up.
Mm-hmm.
So I'll first assume that I do have like max left and max right.
Mm-hmm.
I would want to do like a for loop. So for uh, height, or no, for I in range of length heights, I want to say cur height equals heights at 1, no heights at I.
Mm-hmm.
Then I want to go ahead and get the um, abbreviate that to lm.
Mm-hmm.
So max left at I, and then max right at I. And the amount of water that I could store at this position is going to be bottlenecked by whichever is the smallest between LM and LR. So I'm going to say bottleneck is going to be the minimum between LM and LR.
Mm-hmm.
And then the amount of water that I want to add is going to be, so I have a variable keeping track of the amount of water. And I want to say that the amount of water that I can add at this current position is going to be whatever the bottleneck is minus the current height.
Mm-hmm.
But I want to be cautious of the situation where, let's say in this case, the water could go as high as 2, but the water could go as high as 1, but the wall is higher. So if I do bottleneck minus the wall height, I would get -1. So I
Mm-hmm.
want to go ahead and do a max between 0 and bottleneck minus current height.
Mm-hmm.
So I increment it by that much, and then I return the result.
Mm-hmm. Okay, okay.
Um,
Yep,
is this accurate?
yeah, that makes sense. So basically, for every single element in the array, you want to check out what the current height is, and then figure out what the max left and right. From there, yep, bottleneck, and then like yep, -1. Yep, that's correct. That's correct. Yeah.
Okay, so just to do some polishing up here, I want to go ahead and actually implement the 2 missing arrays that I just
Mm-hmm.
kind of put as ... So I want to go through uh, the indexes
Mm-hmm.
in height. And I could do 2 passes, one from left to right and one from right to left,
Mm-hmm.
but I think I can do this kind of in one go.
Mm,
So right and left and
mm,
right are going to be I, and um, length of height minus 1 minus I. And then I'll say that, so left max, right max, going to be 0 and 0. Or I'll say heights at 0, heights at, no, I'll just go with 0 and 0,
mm,
just in case the heights array doesn't, like it's like empty or something.
mm,
Um, so I'll say that the left max is going to be the max between left max and whatever the new contender is. So height at left,
mm,
and then I'll say that right max is going to be the max between right max and whatever the new contender is on the right side.
mm,
And so once I do this, I have basically two pointers that run through the uh, array one by one, and like left max going in the left direction, and sorry, in the right direction from the left, and right max going the left direction from the right.
mm.
And then I want to, on each iteration, append these results to the array. Um, so max left dot append left max. Now for right max, I'm a little worried because I have to append them in opposite order.
Mm.
Um, I think the best way to do that is just to like put it in the same way, but reverse afterwards.
Mm.
And that's because reversing is just an O of an operation anyways.
Uh-huh.
So I'll do max right dot reverse like that.
Uh-huh.
Okay. And um, so if I were actually writing this in code, some things I would do is I would probably factor out some of this functionality. So I would say like form, um, let's say pre-compute maxes. I would pass at heights.
Mm.
Um, and then I would say probably take this code, put it here. Okay, and then I'll return max left and max right. I'll return max left and max right as a pair like this. Um, and then this can just call pre-compute
Mm.
maxes with heights. And the benefit of this is that if something goes wrong with this code, then I can test this function specifically, like in isolation.
Okay, right.
Um,
Mhm.
and then I think the rest is good to go. This is pretty core to the functionality of the solution itself, so I'll just leave it here.
Mm.
Um, I could refactor it, but I think it's fine to leave it.
Okay, okay. That
Um,
makes sense. Yeah. So
yeah.
just like a follow-up question. Um
Mhm.
like let's say like a word like this element, right? Like a index 0 at like the very left, and like you want to figure out what the maximum like a maximum left one is. What would it be
Yeah.
in this case?
Sorry, could you repeat that?
So let's say like we're calculating the amount of water that can be made for like let's say like the very first one like index 0, or like
Mhm.
the very last one like the length of heights minus 1. For like the one at the very left, how do we figure out what the
Are you referring to
maximum?
the are you talking about the example that I drew out in lines 48 to 52?
Wait, can you see what I'm highlighting? Or oh wait, hold on. Oh wait, actually wait,
Uh,
no, wait, do you see this?
yeah, I do see it. Yeah,
Okay. So what would be the maximum left of this one? Of like the at index 0.
maximum left.
Yeah.
It would. Uh, I think it would be 0 because when I'm computing the maximum left, um, I'm thinking about what the walls. I'm thinking about the walls that could service this location. But if
Mm-hmm.
there's a wall here that's super high, then it can't act towards forming a puddle in this location.
Mm-hmm.
So I think I get what you're getting at, which is that I should offset my pre-compute maxes generation arrays by one, so that it doesn't return um, like it doesn't return like array here where pre-compute maxes would say this position is four.
Oh. Oh.
Is that what you're getting at?
Um. I- yeah, yeah. Like I was just getting like I was getting at that it had to be zero. Um.
Right.
Uh,
So like right now, like the way I've written my function, it it returns like four, 4, 4, 5 like this. When in
mhm,
reality, it returns 0, 4, 4, 4, 4, uh, 4.
mhm.
Is that right?
Yeah. Like you just have to figure out a way so that the like yeah like basically like yeah figure out the edge case. I don't want to like go deeper into it. But-
Okay. Yeah. So I basically need to like uh maybe I need to run this as if there are zeros to the left and right of the array. Um,
Mhm.
yeah, that's what I'm thinking. Like, is this right? So, like, the problem that I'm seeing here is that my function right now, like the pre-compute maxes,
Mhm.
it generates the, let's say, left max array so that it looks like 4, 4, 4, 4, 4, 5,
Yeah.
whereas it should look like 0, 4, 4, 4, 4, 4.
Yeah. Yeah.
Okay, okay. So, um,
Because it
I can
shouldn't
get it to
include the current
say.
one. Oh yeah. Yeah. Keep going. Sorry.
Right, right. So I can so instead of storing the current left max and the current right max, I'd
Mhm.
probably want to store the previous left max and the previous right max. So I could do that probably just by reordering these calls. Um,
Mhm.
so I um yeah, so I append left max first and then I update it.
Mhm.
And of course, it starts at 0 on both ends because like the amount of water accumulated would be the same whether the heights array was appended zeros at the end or if it was just computed by itself.
Mhm.
But in this case, it would kind of generate this second set of numbers instead of the first.
Mhm. Mhm. Okay.
Anything you're still unsure of?
No, no,
Uh,
yeah, that's good. Hmm. Okay, great. Um, yeah, this looks correct. Yeah. So, okay, so what would the time and space complexity of this solution be?
right. So I think good idea is for us to go through the code piece by piece. So we go ahead and pre-compute the max at first.
Mhm.
Here we just do one pass of the array, and then there are no like nested for loops or like all then operations inside of the for loop. So
Mhm.
it's all then, and then reverse is also all then. So pre-compute maxes happens in all then time. In terms of the solution part of the code, like result equals 0, like lines 39 to 44,
Mhm.
that also happens in one pass of the array. So that's all of n.
Mhm.
So all of n plus all of n is like all of n plus n is all of 2n, which is all of n.
Mhm.
So the time complexity is all of n. In terms of space complexity, we just make those two arrays that store the max left and max right, which is proportional to the number of elements in heights. So
Mhm.
that's all of n as well. So this happens in all of n time and all of n space.
Okay, great. Yep, that's correct. Yep, that's pretty good. Congrats.
Okay.
you got the
Okay.
job. No, I'm joking. But like, yeah.
Oh my God. Thank you.
Oh, just a couple things to note. So there is
Mhm.
actually an ov one way to do it, like a ov one
No
space.
way.
Yeah, there is. But like not gonna lie, I watched Nico's video and I was still a little bit confused. So like this like like I don't know how like someone would come up with that in an interview situation. So I think this is like good enough like for now.
I see. I see.
Yeah, like this. Yeah, um, yeah. It's really really good how you went through it. Super good. Um,
Mhm.
yeah.
You know,
So
I
oh.
do actually have like a. I think I think the code that I wrote on my notebook, like the solution that I came up with a long time ago, is of one space.
Oh yeah, yeah. Oh, that's good. Yeah,
But but it's like it's really verbose. So maybe I should like it's like it takes up a lot of code space. So maybe I'll
yeah.
share that later.
Okay, okay. That sounds good. Yeah. Like Neetcode also has like a super simple solution too. But it's like the most
Mhm.
infuriating thing because he spends like 20 minutes like going through the whole thing and then he types in like a really small code. But yeah. But then
I see.
yeah, this was this is like a like the way I like thinking of it, using like the max left and the max right, and then doing that.
Right, right. Okay.
Um, do you want me to like run the code and then like see what's going on, or should I just leave it?
Oh yeah, yeah. Do you want to share your screen and run the code so I can see as well?
Oh, okay, sounds good. Uh,
Or are you able to do that?
yeah, I can share it. Hold up, let me share entire screen. All right. Can you see it now?
One second. Uh, I don't think so. Damn, what's going on?
Uh, shoot, I had this problem with another like programming thing I was doing earlier today.
Oh,
I think it's like a messenger thing. Uh,
oh, okay, okay. Should I call
shoot.
you back on Google? Like you know the like Google calendar invite that you sent me?
Yeah, yeah, yeah. Let's
You want to meet it there?
yeah, sounds good. Already hopping on.
Okay,
All
I'll
right.
see you there.
So, hmm. Bear with me. Some technical difficulties. Uh. All right.
Hello?
Hello, hello. Hello? All right.
Hey man.
Hey, how's it going? Um. Let's have a look. Let's have a look. Oh yeah, I can. Okay. Are you able to see my screen now?
Yeah, I can.
Hi, pipe. Okay, okay. Um. Okay. Let me pull up lead code over. I have like a billion tabs open on my other computer. Give me a second.
Oh, that's all good.
uh, oh, here we go. Okay, so uh, you can see it over here, right? I'll copy
Yeah,
and paste in your code
yeah.
if I can find it. There we go. And then okay, so okay, let me quickly reformat this. Let's
Mhm.
delete
You can get
that.
rid of my test cases too.
Yeah, we'll have put this inside the method over here.
Mhm.
What the heck? And this one, yeah, because that's the end.
And make sure you put in the return statement as well.
Hmm. And then we'll move this indentation a little bit forward too. And then also this. Okay, yeah, indentation looks correct, right? Let me have a quick look again. Yeah, okay, okay. Think I
And
got
then
it
do you
right.
want to yeah, we're making the function called trap. So do you want to just like
Oh
have
my
trap
bad, yeah.
return?
I sorry, I'm tripping, I'm
Yeah.
tripping.
No, that's all good.
And then the variable, we have height, and then
Oh, I have a name that's heights if you want to change it to
oh yeah, yeah. So
yeah.
start off here for
You just need to change it in that for loop.
oh okay, okay.
Yeah.
Heights I. Wait, you mean like this? I need to change it here though, too, right?
Yeah, yeah.
Oh yeah. Uh, Yeah, okay, that's
That's
good.
it, I think.
Okay, let me have a go with the one.
Wait, no, no. Wait, no, no.
Oh, oh, oh,
Change it on line 17 too.
line 17. Oh, there we go.
Yeah, and I think you have some like text pasted below as well.
What the heck? Okay, quickly run this. Oh, okay.
Oh shit.
The dreaded dreaded list index out of range. I hate this one. Okay.
Can you print max left and max right?
Okay. Uh,
Like on line 18.
oh, okay, okay.
Yeah.
Uh, quick run through. Nice. And then this is the result.
Oh, that's so eight.
What
It's
the
not making max right.
hmm. Oh, wait a minute. Sorry, small typo. For
Oh, no, no, no. That's
max
on
right.
me.
Max right.
Okay, okay. Perfect.
That should do it hopefully. Boom!
No way.
Dude, you're gone.
No
What
way.
the heck?
No way. No,
Yo,
that's not real. That's not real.
Okay, let's have a go. Let's
That's
have a
not
go.
real.
Boom! Who's Gordon?
No way.
What? That's crazy. Dude, phone
No
number
way.
misses.
No.
That's crazy, dude. I've never dude, that's not possible.
No way. No way.
Yeah. Dude, you
That's
got it.
fucked. That's,
Dude,
that's
you
actually
got it.
fucked up.
Yeah. Perfect. Dude, you solved the leak code hard like it was nothing, man. Easy money.
No, 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 no. But okay, okay. That's just like I just wrote syntax well, but like the concept you have to basically give it to me.
No. You you expanded on it. I give you like the bare minimum. Yeah. So yeah. Good interview. Dude, you're crazy. You're crazy. Don't downplay yourself. That was insane. Yeah.
Fuck.
Yeah. That's actually yeah, wild. I don't really have any feedback for the interview.
Uh-huh.
Oh, besides like when you mention the time time complexity and you talk about like the for loops, instead of like
Mhm.
saying like there's like I'm checking for like double for loops, you could you could say it
Mhm.
more like CSE, like be like oh like there's no like situation in which you'd be looping through and then you'd have to like go through every single element for each one or something, or like I don't know, like
Right, right.
yeah, something like that. Otherwise, like I think it was pretty good. Yeah, the way you explained it,
Uh-huh.
it's super methodical. Yeah.
Is it?
Yeah, like the way like you came
I
up
feel
with
like
examples and stuff.
I feel like I was like fumbling really hard in the beginning.
No, it's good. I think yeah, like the fact that you kept going is like the good part. Cause
Mhm.
yeah. I think the difficult part is how much time they would give to allocate for this. So,
Right, right.
yeah. If they decide to be like yeah, like lenient with it, like and like go overtime, I think it'd be good. But I don't know how much time to give for hards. That's just like yeah.
Okay, okay.
Yeah.
Fuck, that's crazy. Like, did you stop the recording by the way?
Oh, okay, I'll stop now. Bye. Okay.